pinball. That's the topic of today's show. Did you know that this 400-pound chunk of metal is actually a meteorite, and it basically fell from the sky to the Earth? We're going to learn more about how these rocks are formed and what happens when they hit the Earth and other planets. Let's start by checking in with Amber.
Thank you, Seema. Now, have you ever heard of a comet, a meteor, or an asteroid? You may have heard about them in recent television and movies such as Armageddon and Deep Impact, or read about them in books. And we're going to take a closer look at objects that come from the sky. Have you guys ever seen a falling star? If you have seen a meteor in action. Now, a meteor can be very small, just dust particles, to very large, and it's a miniature version of an asteroid or a comet. Now, once the meteor comes through the Earth's atmosphere and lands on the Earth, it's called a meteorite, and that's what we're going to experiment with today. Now, the first thing you'll need to do are choose different size objects so you can compare the craters. We've chosen 2 different sizes of marbles to compare. You can choose different sizes, different weights, or different densities. Now, Mary, why don't you try the small one, and Sue Ann, you can try the large one. We're going to drop them from the same height in order to compare how the craters are affected. Okay, so go ahead and pick up the ruler. So we're dropping from 12 inches, or 1 foot, and drop it. Perfect. And drop it. Perfect. All right, girls, let's try it on a different surface. Come on in. Drop it. Good job. Now, as you can see, we dropped the meteors from the same height, but the larger one actually created a larger crater because it has a little bit more weight behind it. Now, the white part that came through is called the ejecta blanket, kind of sprayed out. And we can start to see small rays coming out. Now, the marble is sitting on what would be the crater floor. But if it was a real meteor, do you think the meteor would still be intact there, like the marble is? No, you're right. It would actually break up and add to those rays and to the ejecta blanket. Now, the smaller marble didn't quite go as deep, and we don't see as much of the ejecta blanket as with the larger marble. Now, let's take a look at your other ones and see if we can see some of those definitions a little bit closer. Now, Mary, you can see that your ejecta blanket is pretty small. It's about half the size of your marble or your meteorite. Now, let's take a look at Sue Ann's. Now, Sue Ann's, yours is a little bit larger, but you can see it's about the same, about half the radius of your marble or your meteorite. Now, we've changed different size meteors to compare the effects. What's another variable you think we can change?
We could change the height that we drop it from.
Great idea. If we change the height, we can compare meteors coming from different distances and at different velocities. Mary, what's another variable you think we could change?
The surface?
That's another good one. Now, if you change the surface, just like our experiments, you can see it affects the crater very differently. You can compare different areas of the world to see how it's affected. Now, if you want to find out more variables you can change, all the definitions of everything that we talked about today, and more fun information about asteroids and meteors, check out our website. Now, we're going to continue experimenting today as we head back to you, Seema.
Thanks, Amber. Well, remember, at the end of the show, you get to call in with your questions, so make sure that you jot this number down. It's 1-800-522-7126. And now we're going to go to the question of the day, so let's see if you can learn the answer.
What is the difference between a meteor and a meteorite?
Joining us now is Dr. Carolyn Sumner.
Hi.
How are you doing?
Glad to have you here at the
Thank
Burke Baker
you.
Planetarium of the Houston Museum of Natural Science.
And
we've got some friends with us.
Yeah.
You want to meet them?
Yeah.
These are 2 4th grade groups from the Houston Independent School District. We have Burnett Elementary. And behind them we have Port of Houston Elementary. So they're here to learn about comets and meteors and asteroids and all those cool things too.
Well, we have some really smart kids on this show.
I know it.
Earlier we saw some who were learning or making craters out of rocks. But how are real craters made?
Well, these are the kind of rocks that actually fall to the surface of the Earth. And where do they come from? Well, to do that, we have to do a planetarium show.
All right.
Behind us is James Wooten. He's our planetarium astronomer. He's going to throw the switch, and we're going to pretend and lean back and look up and see how these things came from, where they started, okay?
Let's go.
Roll it, James. And what we're going to discover is that 5 billion years ago, scientists tell us that there weren't any planets or the sun, just a cloud of gas and dust.
Is this the same cloud that we see from the Earth?
No, this is long ago, and this is above our atmosphere. This cloud is made of hydrogen and lots of other things all mixed up together, and the cloud is swirling, and that's so important because when it swirls, the material moves toward the center and the cloud flattens out. And this is how our solar system began. Most of the stuff is going to the center of the cloud. That's where the sun is going to be. Now, if you look around, the sun is starting. It's heating up.
So this is how stars are made.
This is how stars are made, and it's still happening today.
Wow.
That's how we know so well what's going on. Now, see those other little blobs? They're pulling gas and dust together. Those are going to be the planets, especially the inner planets, because that's kind of what we're focusing on right now. This one, in fact, is Mercury growing. Now, do you see the planets are orbiting the sun, and they're cleaning up the solar system. A lot of the gas and dust is gone. It's gone into the sun and into the planets. They actually make dark lanes where they've cleaned up everything. Now, the sun starts turning hydrogen into helium. When that happens, energy pours out of the sun, and it blows the remaining material out of the solar system, at least most of it. And now let's go look at one of the planets.
Okay.
We kind of picked Mercury, but that'll do, because it doesn't have an atmosphere, so we can see what's happening.
Which means it doesn't have very much air.
That's right, so there's nothing to disturb our view. And we saw Amber and the kids dropping meteors, so to speak. Well, we're doing the same thing. And the bigger ones make bigger craters, the smaller ones make smaller craters on real planets, just like they do on our labs. Then the planets start to cool. And when this happens, they start separating out. You get a darker stuff in the middle, an iron core, you get a mantle, and then you even get this whiter kind of silicon-based layer on top that becomes the crust of the planet. And if we look, here's where those craters were formed.
Again, those are sort of like the craters the kids were making.
That's right, and here's the real craters of Mercury, and they all look the same. All of them are round. Some of them have little mountains in the middle. These are all meteor craters. Then between the craters, we'll find these strange-looking lines. See them? They have something to do with the craters, but we can't figure out what. If we look down inside the planet to see what's going on, we'll realize the cracks are deep inside. As lava rises, it forms cracks and causes the surface above to collapse. And you get rills and shifts and faults.
And it's the heat of that that's doing that.
It's actually the motion which the heat is causing underneath. And then the lava comes up, and some of it will fill the craters, and you'll have a lot of craters that aren't deep anymore. They're filled in.
Okay.
And notice that then more meteors come. So what astronomers do is they peel away the layers, crater by crater, to figure out the history of a planet, one like Mercury or even like our moon.
I see. Are there craters on other planets as well?
Yes. Other planets are filled with craters. As long as the rock can get to the surface and there's a surface, we'll find craters. But some of the craters aren't impact craters.
Oh.
Let me show you.
Yeah.
James, can you take us to Mars next? All righty, here we go.
Going to Mars.
Going to Mars. And we're going to see on Mars, there's an atmosphere.
Right.
So the atmosphere is going to disturb the surface. And we can see that here we're looking at a large rift valley on Mars called the Valles Marineris. There are craters, impact craters on either side of that valley. So that's an old area, but the valley looks rather new. And we're going to look and see if we can find impact craters inside the valley. The valley was made by the shifting of the plates of Mars. And then, now watch, we're going to sweep around. Everybody kind of hang on here, kids. And look at those craters. That crater is on top of a mountain.
Yeah, that's higher.
What do you call a mountain with a crater on top? Anybody know? A volcano. These are volcanic volcanic craters actually were made from, not from an impact, but from the volcano itself. Notice the old craters. Now we're going to swing through this valley again. Hang on one more time because we're going to go closer. And we discover that wind, because Mars has an atmosphere, so it can have wind, will blow and disturb the dust. We also discover, and it fills in some of the craters as well, so wind can change craters. And this young Rift Valley has almost none. See, there's just no craters in there.
So that's one of the big differences, atmospheric or non-atmospheric is really going to affect the craters.
We've got to remember that when we figure out what causes things. And when there are no craters, it means the area, like the Valles Marineris, is very young. We're coming up on those mountains again. These are the largest volcanoes in the solar system. Arsia Mons, Pavonis Mons, and Ascraeus Mons is perhaps the tallest mountain. Now, of course, there's a crater on top, but it is a volcano. So you get an idea when you go, no matter where you go, you're going to find craters, and you're going to find things that weren't caused by craters. Cool?
Very cool. Well, we have been seeing a lot of craters on lots of different planets. And but how are they, and what kind of impact, I wonder, do they have when they get a little closer to us here on Earth? I think we should go over to the Science Theater with Dick and Jane and check that out.
The sky is falling! The sky is falling!
What on earth are you doing?
Get down! Dig a hole, quick!
Why?
Why? The sky is falling, that's why. Do you want to get hit by a piece of the sky? It could hurt a lot.
Look, the sky is just where it ought to be.
It's just to fool you. It's just waiting for the right moment, and it will all come down on our heads, and that will be that. Ah, there!
Where?
There! There! A piece of the sky has fallen off! Run!
That's not a piece of the sky. That's just a shooting star.
The sky is shooting at us? Ah!
You look very silly.
Silly? We're at war! The stars are shooting at us and I can't shoot back! We're done for!
A shooting star is just a name for a meteor, that's all.
The meteors are shooting at us too!
Don't you know anything? What you're scared of is a small meteoroid that's come into the Earth's atmosphere, that's all.
So we're at war with the meteors and the meteoroids? Call the president!
Dick, come up out of there. A meteoroid is called a meteor when it enters the Earth's atmosphere and burns up. If a meteor reaches the Earth's surface, it's called a meteorite. Shooting stars are called that because that's the way they look, zapping across the sky.
I get it! I get it! What's a meteor? Whatever.
They're bits of solar system that fall to the Earth.
The solar system is falling! The solar system is falling! The solar system is falling!
Will you calm down? You're going to cause a riot. Come on, there's something I want to show you.
Where are we going?
You'll see.
How did it get to be night so fast?
Just the power of television.
Oh.
Now stand here and look up.
What if I get a meteor in my eye?
Look.
It's an invasion! The Martians are attacking!
No Martians, Dick. It's a meteor shower. Isn't it pretty?
Pretty? Those are Martian spaceships with little green men inside.
Nope. A meteor shower happens when the Earth passes through a stream of debris in space.
No spaceships?
No spaceships. Come on.
Where are we going now?
Winslow, Arizona.
What? How are we gonna get to Arizona? I know. Television. Oh my gosh! We've been bombed!
Nope. That's the Barringer crater. It was caused by the impact of an iron meteorite more than 50 meters in diameter.
Wow! Should we call somebody? When did it happen?
About 50,000 years ago. And the meteorite that caused it was so big it made that crater, which is 1,200 meters in diameter and 200 meters deep. There are more than 1,000 meteoroids that cross the orbit of the Earth, but
I want to go home. We'll build a shelter. Warn everybody. Those meteors are going to destroy the Earth.
I don't think so.
What if we get hit by one tomorrow?
I wouldn't worry about it. A large meteorite only hits the Earth about once every 300,000 years.
But this could be the year. I'll never sleep again.
I wouldn't worry about it.
Not worry? Look at the size of that thing.
Craters that big only happen once every 100 million years.
Oh, I'd be real old when that happens.
You'd be the oldest person in the history of the world.
Oh, I'd like that.
Oh, don't count on it. Come on, let's go home.
Well, thanks, Jane. I guess I won't be so worried about space and theaters anymore. Ah! Oh. The Martians are invading! Oh.
Dr. Subners, what are the real chances of a meteorite hitting the Earth, or a significant one?
Well, it depends on how big it is. We get little pebbles every day.
Right.
10 or so of them. Every year, every week or so, we get a rock this size falling somewhere. Something the size of an automobile, every 10 years or so, will hit the Earth. Something the size of a house would hit every 100 years or so, and be significantly important.
When was the last major one that we had?
Okay, if you go back 65 million years, I mean, this is going to be major. We had a rock, actually it was an asteroid from the asteroid belt that hit the Earth. It was over a mile wide, but less than 10 miles wide. It hit the Earth in the Yucatan area and destroyed the dinosaurs, and over half of all living things died from the effects of that one big asteroid.
That is a very interesting theory, but since that happened that long ago, is there another one maybe coming right around the corner?
Chances are the longer we wait without, the less chance we are of getting hit. But if you hang around long enough, the rocks are out there. We've seen them. We can see them through our telescopes. Eventually, one's going to hit us. And also, comets could hit us.
Comets? You mean we have something else to worry about?
The
We have something else to worry about?
Yes. In fact, we're making a model of a comet. You want to see it?
Yeah.
Josh and Manuel are helping James, our planetarium astronomer, actually make a comet model. Now, to make a comet, and you can do this in your home, ask your mother first. You need Karo syrup or molasses or some syrup to get hydrocarbons. You need sand. Manuel is putting in some charcoal, which he got from charcoal briquettes. Josh is adding sand. You need some silicon, so sand will do that. Then, of course, you need water, and you stir all that up first, and then James is putting in the dry ice, or carbon dioxide ice. And here we go. Are you ready? This is going to make the comet turn into the icy thing we're used to, and this whole crowd may disappear into a fog.
This is like a snowball effect.
That's right. That's right. And the result in that bag should be, when they're through, a comet.
And this is cold ice making that smoke.
Yes.
So what is a real comet, though?
Well, while they stir up their mess, let's check on what a real comet looks like. If you look in the sky, comets are dirty snowballs with long tails. And now we're going to look at the nucleus of a comet, and we discovered that in the nucleus of a comet, you can actually break up. Comets are kind of chunky. And as we watch comets, we realize that from that nucleus, a tail can form.
And they're separating.
This nucleus actually of Comet West separated. Now you can see different kinds of tails. Some tails are mostly gas. Some tails have dust in them. This is Halley's Comet in 1910. Notice how the tail changes and grows as the comet swings around the Earth and around the sun as it comes in. Comets spend most of their lives in the cold outer solar system. Only a little bit of time do they get to shine and make a pretty long tail. This is the path of Halley's Comet in 1910. Now the blue dot is the Earth. So here the Earth, we're going around the sun. The comet's coming in at the top part of the screen, coming down, swinging around the sun. Now it's going to start to grow a tail. There it is, and the Earth actually went very close.
Wow, how big is that tail?
Well, a tail is very long. It can be longer, like 93 million miles, as long as the distance between the Earth and the sun, but it's very thin. It didn't bother the Earth to go that close to it.
Is it made up of the same type of substance as the actual comet?
It's the dust and the gas of the comet. And now we're seeing 1986. Here's the Earth, and there's the comet. And notice the comet stays much further away from us this time. So in 1986, most people didn't see Halley's Comet. At least they didn't see it very well.
Right.
Now we're going to go in with the comet. Notice the orbit is long and cigar-shaped. So once again, comets are not a threat until they get close to the sun. When they get close to the sun's heat and light actually cause the comet to melt, and we begin to see the comet change, and we end up with the thing that we saw James and his assistants making a minute ago. So here we go in, following the path of the comet. The planets have nice circular orbits, not comets. Comets' orbits are very long and skinny. And that's why we don't know how many comets there really are, because they just come out from all over the place.
And what is this closer look?
This is the nucleus of Halley's Comet. It looks like a peanut. And if we look at it up close, it's dark on one side. That's where the sun isn't hitting. But look how bright it is on the other.
What a difference.
Yeah, those are jets. And we saw that dry ice puffing out all over the place when they were making our comet. That is the same kind of stuff that spews back and makes the tail of a comet. And there you can see us drawing the jets as we saw them, and we'll even diagram this. And this is the only picture we have of the head of a comet, because Halley's Comet is the only comet that came close to us we could predict and actually send a spacecraft called Jnco.
And we kept a pretty good watch on that one, didn't we?
We got a lot of good views of this comet. Any rate, so basically these nucleuses are no more than 10 miles or so. They could be up to 50 miles wide if the comet's very big, but you don't want to be hit by one of these either, because they're traveling very, very fast, and they could package quite a wallop. You want to go back and see how the comet making ended up?
Let's see how their comet is close to the one we've been looking at.
Oh, they're pouring it out. Let's get a look at this mess. Now, comets look like chunky, yucky, dirty snowballs.
They really do.
And I think James has made one chunky, yucky, dirty snowball. Wow, and see, the comets are kind of clocked together. We expect that to be the case. There's going to be dark colors from the charcoal, the sand, everything mixed together. And then the stuff that comes off the back of the comet, when the comet comes close to the sun, look at all, James will tilt that toward the camera, look at all that mess. Okay, a lot of that stuff is shed by the comet, goes into the comet's tail, and when the Earth goes through the tail, or the leftovers, we get the meteors. And so the shooting stars that you see go whooshing by actually are the leftovers of a comet.
Oh, wow.
Isn't that cool?
And so that ice that's making that smoke, that's similar to the tail.
That's the material, the same kind of material you'd find in the tail. It's called carbon dioxide. It's a prominent, carbon dioxide and water are very prominent in a comet.
Okay. Well, I'm sure all of you have a lot of questions, but before we go to your questions, let's see if you got the answer right to the question of the day.
A meteor is a shooting star, a piece of dust, rock, or metal that passes through Earth's atmosphere and heats up, and it leaves a trail behind it. A meteorite is a rock that comes through Earth's atmosphere and lands on the Earth.
Well, it is now time to take your questions, so please give us a call at 1-800-522-7126. And I believe we have one question right now. Diane from Austin. Diane, what's your question?
I was wondering, how did the craters get filled in on Mercury?
Okay. Underneath Mercury is magma, kind of like there is for the Earth, at least when Mercury was young. It was molten underneath, and that material could rise up and actually flood the craters. And this also happened on the moon. If you look at the moon tonight, you'll see dark seas. They kind of make the eyes of the man on the moon. Those dark seas were filled in by magma or lava coming up from inside the moon and filling in the very early crater basins. That's a great question.
Okay, and we have another question. Sherry from Thousand Oaks. Sherry, what's your question?
I was wondering how many about how many meteors hit Mars every year.
Okay, I think I know what you're asking. Mars goes around the Earth, around the sun, at half the speed approximately that the Earth does. So if you are 10 years old right now, like these kids are, you'd only be 5 years old on Mars, because a year is almost twice as long.
Speaking of the meteors, what makes a meteor shower?
A meteor shower is a time when we go through the leftover pieces of the tail of a comet. Right now, we're going through the debris stream from Halley's Comet. The best meteor for this year is coming up in December, meteor shower, about the 13th of December, It's called the Geminids, and we'll go through a tail of a comet, and you'll see lots more meteors if you go way out in the country where you can see them well.
Okay. And then also,
you want to ask the kids if they have a question?
Yeah.
Anybody
Let's
have
see.
a question?
Do you have a question? What's your question?
Can I see a comet tonight?
Hey, that is a great question, because you can see not comets, but the meteors that are left over from them. We can't predict when you can actually see a comet, because once you know how they come in all those funny orbits from all over the place, like Halley's comet. Only Halley is the only one we can really predict. But if you go to your local planetariums or observatories or even museums or astronomical societies, they always tell the newspapers and the television stations when a bright comet is coming, so you'll know in plenty of time to go outside and look. Okay?
That's a great question. Do we have any other questions in the audience? Do you have one? What's your name?
Albert.
What's your question?
How did the dinosaurs die?
How did dinosaurs die?
Oh, okay, that is a great question over there, because the big asteroid didn't just fall on the dinosaur's head. And what really happened was when the asteroid hit, it caused a lot of dust to get up in the atmosphere. It changed the atmospheric composition. It caused freezing, and the dinosaurs died from the cold and the stuff.
Okay, well, that is all the time we have for this show, but thanks for watching. Visit our website at www.hmns.org for learning activities and other museum information. You can also email us at quest@hmns.org or write us, attention Science Quest, at 1 Herman Circle Drive, Houston, Texas, 77030. Explore some of the most significant discoveries in the history of natural science exploration on the next Science Quest, Biology, Voyages of Discovery, Tuesday, November 28th at 10 a.m. See you then, and stay curious.